Once again, we're going to take a look at another planet in our solar system, the second planet from the sun. You'll be filling out this note sheet here. You filled out the top already on Mercury. Now you're going to fill out the middle section on Venus. You can take a look at this picture of Venus. You can see that Venus definitely looks different from Mercury. You can't see the surface, all these clouds in the way. So let's find out about Venus. It is a rocky planet also, very similar to the Earth, very similar to Mercury and all the inner planets. It's 900 degrees Fahrenheit. Why is that? Well, we learned that Mercury has this huge 1,000-degree temperature swing, and the reason why is it doesn't have an atmosphere, so when the sun hits it, it heats way up, and when the sun goes away, it cools way down. So on Venus, it stays the same temperature all the time. It's also a small planet, the sixth largest planet, so there's 5 planets larger than Mercury. It takes 243 days for it to spin around one time on its axis. Now, you can think whether or not the planet here has a magnetic field based on your understanding of magnetic fields. It takes 225 Earth days to go around the sun one time. It should take less time than Earth because it's closer to the sun than the Earth. It should take more time than Mercury because it's farther away. But what's super weird is it spins around slower than it takes the time for it to orbit the sun. Crazy planet. It does not have a magnetic field, spins too slow. No moons. Think about why Mercury didn't have moons, and that's why Venus doesn't have them. It does have a thick atmosphere of carbon dioxide. 95% of the atmosphere is made of carbon dioxide. I know you've heard of carbon dioxide before. It does have some interesting surface features. You can't see them obviously in the image, but if we use radar to penetrate through the clouds, we can map the surface, and we've done that. It does have plains, lots of flat areas, a few volcanoes, and a few craters. So very, not a very detailed surface like some of the other planets. Might have something to do with the atmosphere. It does have some unique features. It's tilted 177 degrees, which is virtually upside down. It has a retrograde rotation, which makes sense if it's upside down, that we'd be spinning the opposite direction that it's rotating. So all of the other planets, they spin the same direction that they're orbiting, but if it got turned upside down, you can see how it might be spinning the other direction. It's referred to as Earth's sister planet, which means that it's roughly the same size, has the same gravitational force, has the same density, mass, etc., very similar to the Earth, and so we call it Earth's sister planet. Several spacecraft have visited, a couple of notable ones. The Russian Venera 7, that picture's on the bottom. It actually landed successfully on the surface and functioned for just a little bit less than an hour, sending back some images and some data. And then the Magellan orbiter, which you can see pictured above here, that was launched in 1996 from a shuttle bay in orbit around Earth and then traveled off to Venus and orbited for roughly 10 years, mapped the entire surface of Venus and just exploded our knowledge of that particular planet due to that orbiting spacecraft and all the time it spent there gathering data. So there are some very unique things about Venus. It has these very, very thick clouds. They block out the sun. So think of it when it's really smoky here, or in the winter when we've got thick clouds and the sun's just like a blurry spot in the sky. That's what it's like there all the time. There's lightning in them, 200-mile-an-hour winds, and it rains sulfuric acid. And the atmospheric pressure is 90 times the Earth's atmospheric pressure. It's like when you jump in the lake and you swim down the lake, what happens the deeper you go? Your ears hurt, right? Because your eardrums are the weakest part of your body at resisting pressure change. And so they're saying, ow, pressure is changing. 90 times the Earth's atmospheric pressure is like being 3,000 feet underwater. So you can think about what would happen to you if you were 3,000 feet underwater. Not particularly good. Now you can see why the Russian Venera spacecraft didn't last very long on the surface of Venus. Okay, you're done with this. Make sure you have those notes on your note paper. All of those notes will be important because you'll get to use them on your test and you want them to be organized and easy to get to. Now, you are going to do an assignment today. It is not going to be due today. It's a long-term assignment, okay? And it's actually going to be due Tuesday, the week of October 19th, okay? So quite a ways from now. But the reason why I'm giving to you now is because as we talk about the planets, you'll be able to do the assignment with a little bit more information from each planet as you go. Some of you will get crazy. You'll look it all up on the internet and you'll get it all done in a hurry. I don't care which. It's not due for a couple of weeks, okay? Here's what you're going to do, this massive crossword about our solar system. All the clues are on the back. Please, 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 please help yourself out. Use this because the information that we get here we'll help you on there. And it's hard to find it in other places. Not impossible, but hard.